Welcome to RSET Online. I am Krishna Kumar KP, working as Assistant Professor in Department of Applied Electronics and Instrumentation, Rajgiri School of Engineering and Technology. Today I'll be covering on fourth module topics in AE472, Petroleum Engineering, compressors, pumps, pressure vessels and LNG compressing process. Now my contents are organized as follows: introduction, compressors and pumps, heat exchangers, storage vessels, and finally LNG production flow process. Introduction. Pumps, compressors and heat exchangers, apart from storage vessels, forms an integral part of LNG compressing process. Towards the end, I'll be discussing on the process flow diagram of LNG compressing. Now let's look into compressors and pumps. There are mainly two types of compressors and pumps used in process industries. One is centrifugal type and the other one is reciprocating type. Apart from this, screw compressors are there and gear pumps are there, which we will not be covering in the portions. Now coming to centrifugal pump. The centrifugal pump works with very simple principle. Whatever material collected into this rotating vane chambers will get thrown away to the peripheral of the casing by centrifugal force when this vane rotates or the blade rotates. Okay, so the principle, the fluid that enters into the chamber where the impeller is placed through the suction side, and the fluid in the veins or blades experience a centrifugal force and will move towards the discharge section. This portion consists of the discharge section. You can see the discharge section here. Now centrifugal compressor also works in the same principle, but the difference between centrifugal compressor and centrifugal pump is centrifugal pumps are used for liquid applications, whereas centrifugal compressor is used for compressing gas. So here also the whatever fluid that is coming into the chamber is thrown away to the peripheral side by this rotating vane, and that is shown in the block diagram here. The arrows represents the fluid flow. Okay, next portion comes with reciprocating compressor. Reciprocating compressors has a piston and a cylinder arrangement together with suction valve and discharge valve. So during the forward stroke motion, the fluid gets sucked into this chamber. The gas gets sucked into this chamber, and during the upward stroke, this valve will be closed. The suction valve will be closed, and discharge valve will be open, thus delivering compressed air into the discharge session. Now next portion consists of shell and tube type heat exchangers. Heat exchangers are required in the operations like natural gas compression stage. Apart from this, also during crude oil distillation process, one need to condense the volatile liquid, so we need the heat exchangers for that. Based on the principle of it works on the principle of thermodynamic heat transfer between hot and cold fluids. The more area of contact leads to more heat exchange for fluid in flight. So shown in figure is a diagram of a typical shell and tube heat exchangers. This portion represents the hot side, and this portion along with this tubing represents the cold side. So this can the working principle of heat exchanger is very simple. When fluid in the hot side flows in this direction and the fluid through the cold side flows in this direction, the heat transfer will occur in the contact area. Thus naturally the hot fluid will get colder and the cold fluid will get hotter. This can work in two different modes, counter current and co-current mode. In counter current mode, both the heat, the material flow will be in the opposite direction. That is, the hot side, the fluid will flow in this direction, whereas at the cold side, the fluid will flow in this direction. In co-current mode, the opposite occurs. So next portion to be covered is pressure vessels and storage tanks. When storing compressed natural gas, we prefer spherical shapes as shown in this figure. This is called this kind of storage vessel is called the Horton sphere, and when we need to transport LNG or compressed gas in trucks or any other motor vehicles, we have to go for bullet tanks like this, which is cylindrical in shape. What is common with both two shapes are it is not having any edges, as you can see from the figure. So when large storage with high vapor pressure is required, the best option is being spherical, called the Horton sphere. In other applications like mobile transport, you can go for cylindrical bullets. It's called bullet tank. The spherical and cylindrical shapes are easy to construct, and the analysis of safe operations can be done very easily in this kind of clear geometric shapes. Now we are coming into the concluding part, the process of LNG compressing. As recalled from the previous classes that we are having two manifolds, production and test manifolds are there, as well as injection manifolds will be there. Some part of this well will be injection wells, which will be injecting water towards downwards. So whatever petroleum plus gas formation that is coming, petroleum plus gas that is coming from the formation will first enter into a production separator. Production separator is a simple vessel. It separates based on the density difference of the material. Simple principle on gravitational separation. So the first thing, the gas will bubble upwards and it will go into a centrifugal compressor here. After compressing, that comes into a heat exchanger over here, where the compressed gas will be cooled. It can go in again go into another stage of HP compression. HP stands for high pressure compressor and LP stands for low pressure compressor. And from there it is taken to the pig launcher where the gas can be exported into gas pipeline. And whatever oil that gets separated will go into a second stage production separator, where further of the water will be removed. Water will settle into the bottom portion of the tank because it is having highest density. That will be removed, it will be treated and sent back to the environment itself. And whatever oil that is collected from the production separator is stored in oil storage, and that is also taken into a pig launcher to the oil pipeline, or an oil tanker will take away the oil. Okay, now concluding, I would like to introduce you to reference. This is a good reference written by Howard DeWalt. You can download it from www.abb.com. It's called Oil and Gas Production Handbook. Okay, so coming into the concluding session, we'll see later on in the session. Okay, thank you.